All right, today we're going to talk about area of circles and regular polygons. Area of a circle should be familiar. We've talked about that before. Area of a circle is pi r squared, and the circumference of a circle is 2 times pi r. Another way to say that is 2 times r in a circle, of course, is the diameter, or diameter times pi. So that's enough about circles. Let's go on to the hard stuff. The hard stuff is about regular polygons. Now remember, regular polygons are polygons that have sides that are the same, that are congruent, and angles are all congruent. So we're talking about regular polygons, and area for a regular polygon is 1/2 the apothem times, and it's a lowercase a, times perimeter, which is a capital P. So A is the apothem, or apothem, depending on how you want to say it. Tomato, tomato, right? And P is the perimeter of the regular polygon. So what the crap is a apothem? That doesn't even, never even heard of that. Let's talk about that. If you let's draw a hexagon. And mine is a terrible hexagon, but you get the gist of it. And an apothem is from the center of a regular polygon. It'd be from the center, and it would drop straight down to bisect one of the sides. This is the apothem. Now, the apothem, if you draw this other segment from the center to a vertex, this here is called a radius of a regular polygon. I know it's kind of a strange word for a polygon, but that is a radius. We'll talk more about why that is tomorrow. But for right now, an apothem is from the center to the midpoint of the opposite side, so it bisects this. And the radius is from the center to a vertex. All right, and this triangle, this right triangle, is going to be very useful. Let's get into it. Let's do our first example here. Let's talk about with a hexagon. Hexagon has an apothem of 6√3. Find the area. All right, so I'm a visual guy. I got to see it, so I'm going to draw a little hexagon here. Oops, well, that's even worse than the last one. But, all right, so it says the apothem is 6√3. The apothem is 6√3. And if we draw that radius, I'm going to draw a radius here. And I'm going to focus in on this triangle right here, this triangle that we made, that's the right triangle. As I said before, this was going to be useful. I'm going to blow up that triangle so it looks like this, where the apothem is 6√3. And there it is. Now, one of the things that we've got to remember about a hexagon is what each interior angle is of a regular hexagon. And I'm sure that we all remember that each interior angle of a regular polygon is 180 times n minus 2 divided by n, and that will give you what each interior is. All right, but here's the thing. I don't want to do that one. Instead, imagine that if we drew just our radiuses, our radii. Oh my goodness. How many of these triangles would we have? Well, there'd be 6 of them. Right? There's 6 pieces of this pie. And so a circle is 360 degrees all the way around. So 360 divided by 6 is 60. So that means that each piece like this is 60 degrees. So coming back here, when we dropped our apothem, this 60 is actually bisecting. This is 30 apiece. 30, 30, 60. So what we actually have here is a 30, 60, 90 triangle. All right, why are we doing all of this? Well, remember, area is 1/2 the apothem times the perimeter. Now we've got the apothem. What we don't have is the perimeter. We know nothing about this here perimeter. So if this is 6√3, this is a 30, 60, 90 triangle, which means that opposite the 30, you got to find for your 30, 60, 90, this would be 6. And just for fun, the radius is 12. Anyways, taking this triangle and putting it back here, this piece is 6. So how big is this entire side? This entire side would be 12. Thus, the perimeter of this hexagon would be 72. All right, so now we've got the apothem, we've got the perimeter. Area is equal to 1/2 the apothem, 6√3, times the perimeter, which is 72. So the area of this regular hexagon would be 1/2, 3 times 72 is 216√3 units squared. That would be our area here. All right. Hexagons are nice because we can use 30, 60, 90s, and that's nice and everything. But what if it's not quite so nice? There's some other tools that we might have to use. Let's talk about a pentagon. And a pentagon has a perimeter of 70. And again, we're going to find the area. Now, this is a regular pentagon still. So, draw a regular pentagon. I like to make dots sometimes to make it. Maybe this one won't come out quite as nasty as my other hexagons. Well, it's not a very good pentagon, but it's there. Okay, so again, let's draw our apothem that goes straight down from the center to the bisects the other side, and draw the radius, and I like to draw that outside. So I got my right angle. So the perimeter is 70, then how big is each side? Well, there's 5 sides. 70 divided by 5 would be 14. So each side is 14, which means that on this little part of our triangle here, this part is 7. All right, this time we know the perimeter. What we don't know is the apothem. Now, pentagon is not going to give us a 36, 60, 90, or a 45, 45, 90 for that matter. So, again, if we were to make these little triangles like this, from vertex to vertex, we would have 5 of these triangles. So 360 divided by 5 is 72. Each one of these triangles is 72. So then, on our model here, this is half of that 72. This is a 36-degree angle. All right, so we're trying to find the apothem, A. It's not a 30, 60, 90. It's not a 45. We can't use Pythagorean theorem. We're left with, you got it, SOHCAHTOA. We got to use trig here. So with this angle here, this 32 or this 36, we're using the opposite and the adjacent. That's going to be a tangent. Tangent of 36 equals SOHCAHTOA, opposite divided by A. So 7 divided by the adjacent. So that means that A times the tangent of 36 is 7. A is 7 divided by the tangent of 36. So if you use your calculator there, that is approximately, make sure you're in degree mode, you should get approximately 9.63-ish. All right, great. So now we've got our apothem. So the area of this thing is 1/2 the apothem, which we got, 9.63, times the perimeter, which they told us at the beginning was 70. So 1/2 times 9.63 times 70 is approximately 337.21, and again, arbitrary unit squared. 337.21. All right, let's do one more. Make sure you all got this. Last regular polygon is going to be an octagon. An octagon in the apothem is 60. So, again, we're going to find the area. Find the area. I like to draw it. So, with an octagon, I'm a dot guy for octagons. So I got to draw them. Put the dots of a stop sign, and then connect the dots. Fa la la. Well, that's the best shape I made all day, and it's still a little bit far apart up in here. Anywho, so I like to draw my triangle. There's my apothem. There's my radius, right angle, and I draw that triangle outside. The apothem is 60. So we still got to find the perimeter. Now, the perimeter, am I worried about the hypotenuse of my little triangle, or am I worried about the other leg? I want the other leg. So I'm looking for this. I don't know the hypotenuse. Again, we got to figure out our triangles. If we take 360 divided by 8, 360 divided by 8, you would get each one of these is 45, which means that our half a triangle here, the apothem bisects that 45. This angle here is 22.5. So I'll tell you what, let's pause the tape, go ahead and work by yourself or with your people and see if you can find this here area. Go ahead and pause it and we'll come back and we'll do it. All right, so hopefully y'all got 22.5. We're going to do another tangent here. So the tangent of 22.5 is x divided by 6. So x is, oh my goodness, x is 6 times the tangent of 22.5, which is approximately 24.85. So if the x is 24.85, this is 24.85, that means that the entire side would be twice that, or the perimeter would be 24.85 times how many of these little half pieces will we have? We'd have 16 of them. So 24.85 times 16 would be approximately 397.65. So, guys, the trick to these problems, if you have the apothem, find the perimeter, or vice versa. You got to find the apothem, you got to find the perimeter. Area is 1/2 the apothem, 60 times 397.65, which is approximately 11929.35, 11,925.35 arbitrary units squared. All right, so that's how we do the area of circles and regular polygons. You got some homework to do. Go ahead and hook it up.